I'm Adolph Oliver, and this lesson starts our treatment of word problems. We're going to look at them in detail because this is an area that often takes a lot of study, but there are patterns to these, and once you learn these patterns, you can handle word problems easily. Well, we're going to start with one-step word problems, and here's the first idea on this. Many of these that we're going to look at now are going to be pretty simple to start out with. They're going to get much more complicated later, but these simple ones to begin with, you could look at and figure out by trying values in your head, basic math calculations, what the answer is. Do it by what mathematicians often call inspection. But resist doing this. Don't do this, because here's the idea. The simple methods we're going to be talking about here are the building blocks to be able to handle more complicated problems later on. So you need the practice in using these methods for the simple equations. So to kind of emphasize that, for each of the problems that you do here in the class, whether it's on the exams or in the homework, we're going to require you to give not only the answer with the units, if it's a word problem here, but also the equation that you use. Now, you might end up using different letters, and there's no problem with that. And there are slightly different forms of an equation that will give you the same answer. But the key is that you've got to come up with an equation to be able to solve the problem, because that's going to be the building blocks that we use for more complicated things later on. Well, let's look at a very simple example to begin with, and we'll look at a number of homework examples. Okay, here we go. The sum of a number and 7 is 12. Now, this is not difficult to figure out what it is just by looking at it and trying some things out. But we're going to show you how you can start breaking this up. And we've mentioned to you before one of the beginning secrets here, and that is if you've got a one-line problem like this, is there a word in here that can be replaced with equals and it won't change the value, or the meaning I should say? And the key, of course, is the is the word here. If you turned around and replaced it with equals, the sum of a number and 7 equals 12 means exactly the same thing. Now, of course, we're not going to have just one-line problems coming up here, and things will get much more complicated than this in the future. But what this means now is that, of course, is where the equal sign goes. What do we have on the right side? The 12. On the left, the sum of a number. Let's say I use n for number. And the thing you have to remember, of course, is sum means we're adding them. So the sum of a number and 7, we've got n plus 7 equals 12. Okay, there's your equation right there. That would be one of the things that you'd give in the answer. Then, of course, you want to solve this. So, as we've done many times before here, our guide to solve this now, we want n equals whatever number the answer is. Well, n's are okay on the left, so this n term is fine, but the plus 7 has to move. Numbers are okay on the right, so the 12 is fine. So I've got to move the plus 7. When it jumps the other side of the equal sign, we've got negative 7. Now remember, once again, when you jump terms one at a time, the sign changes of the term. If you were to completely swap both sides, nothing would change. So that's the difference. Changing the sides wholesale, no change in sides and signs. But when you jump terms one at a time, then the sign does change. Okay, well, the plus 7 became negative 7, so we simply end up with n equals 12 minus 7, which is n equals 5. Okay, well, this is a simple example to remind you again of the process. Now let's take a look at some of the word problems that we have in the homework that are a bit more involved here. Not quite this simple, but still easy to set up and solve. Okay, here's the first stop. And we can certainly have a little bit of fun with these guys. So this one says, a mean org stole 10 of your muffins. That was 2/3 of all of them. With how many did you start? Okay, well, they want us to figure out how many muffins you had to begin with. So a good thing to do is always define what your variable is. Let's use M for muffins. So M is going to be the number of muffins, okay, at the start. Now, the thing we know about this is the following. What the orc took was 2/3 of those. Well, that means he took 2/3 of the M. Well, 2/3 of the M. If I was taking half of M, I'd be multiplying by 1/2. So 2/3, I'm multiplying by 2/3. So 2/3 times M would be the number of muffins he took. And they also told us that that happened to be 10 total muffins. The orcs told 10, and that was 2/3 of what you had to begin with. So here's the 2/3 you had to begin with, also equals the 10 that were taken. There's our equation right there. Okay, again, you could have used a different variable, but you'd have a form like this. Now, to solve this, it's real easy. If you have a fraction times your variable, simply multiply by the reciprocal of this guy. Remember, our goal is to have M equals what the answer is. I want to get rid of this 2/3, change it into 1. How do I take a 2/3 and change it into 1? Multiply it by its reciprocal. But of course, if I do that to one side, I've got to do it to the other side as well. So here it is over here. Well, the 3's cross cancel, the 2's cross cancel. That's what reciprocals do. We end up with 1 times M, or simply M equals. Now over here, 2 goes into 2 once. Remember, I could make a fraction by putting a 1 underneath that 10, so that reminds me that 10 is upstairs. So 2 goes into 2 once. We're cross-canceling. 2 goes into 10 5 times. I have 1 times 1 is 1 downstairs. So the answer, when the downstairs is 1, is just the upstairs. 5 times 3, which is 15. But now, these are muffins, so make sure that you label what the things are. One of the requirements for sure in a word problem is that you put the units down, indicate what they are. M equals 15 muffins. These are the muffins that you had at the start. Okay, well, here's another problem. Alberto was given $17 for a good report card. He now has $22. How much money did he have to start with? Let's say, well, we use M for money again here. M equals the money at the start. Okay, it's what he begins with. So, we have the M, and he was given $17 more, so whatever he had to begin with, the M plus the 17 extra he was given, now has to equal 22. Well, once again, there's the equation that we have here. You could use a different letter, but whatever you started with plus the 17 he was given equals the 22 that he now has. Okay, well, as always, if we were solving for this, remember our goal is to have M equals whatever number the answer is. So you ought to be getting pretty used to this by now. The guy that needs to move here is the plus 17. Everybody else is on the correct side. So this comes over as negative 17. Plus became minus. That's correct. So M simply equals 5. Now, the monetary units here are dollars, so be sure you put the dollar sign in on this. Okay. Here's another problem. We've got some mixed numbers in this. Let's show you how we're going to work with these. A recipe for muffins calls for 3 1/10 cups of flour. Well, he accidentally put in 5 1/6. That's a bit more, okay? How many extra cups did he put in? Let's say E equals the extra cups. Okay, now, how much was he supposed to put in? The 3 1/10. But what did he do? He added some extra to that. Well, what are we using for the extra? The e. So here's the original amount plus the extra has to equal the total amount that he did put in, namely 5 1/6. Now, you could solve this with the mixed numbers, but most commonly in word problems here in the algebra, we're going to be converting these to improper fractions. So let me do that here. Remember, there are different ways that you can tackle these guys. So, different approach, as long as you get the correct answer, is perfectly fine. Okay, let's convert these guys to improper fractions. 3 times 10 is 30 plus 1 gives me 31 over 10. Okay, that's the 3 1/10. Plus the extra equals, now over here, 5 times 6 is 30 plus 1 is 31/6. Okay, so the 5 1/6 became 31/6, 3 1/10 became 31/10. Now, we have different denominators here. I'll make a fraction out of this guy just to keep us honest as we go on here. Let's clear the fractions out. So what we need to do is figure out what the LCD is. Again, work with the largest denominator simply because you get the answer quicker. We're going to think of the multiples of 10. Now, the only thing we have to worry about is the 6 dividing into it. First multiple of 10 is 10. 6 won't divide evenly into 10. Second multiple of 10 is 20. 6 won't divide evenly into 20. But the third multiple of 10, which is 30, 6 does divide evenly into. So the LCD here is 30. Okay, well, remember how we've solved equations with fractions. We're going to clear out the fractions by multiplying through by this LCD 30. That means I'm going to hit each and every term on both sides by 30. Remember that this is a balance scale requirement, so don't goof this up. Notice I've hit both the terms on the left and the one single term on the right. Now, cancel out the denominators. If this is the correct LCD, it will take them all out for you. 10 goes into 10 once, it goes into 30 3 times, so there's 3 left. This guy already had a 1 downstairs, so the full 30 stays up here. The guy on the right side, 6 goes into 6 once, 6 goes into 30 5 times. Okay, well, there is all the denominators gone, so we've taken care of the fractions. Now, as before, carefully put the leftovers together. Plus 31 times 3, well, 3 times 31 is what? I think it's 93, isn't it? Then plus 30 times e, well, that's just plus 30e, equals over here, plus 31 times 5, well, let's see, I think that's going to be 155, isn't it? Now, here we go. We want to solve this. Remember now, of course, our goal is to get e equals the answer, so e equals whatever number the answer happens to be. Okay, who do we have to move? Well, the 30e is okay on the left. The 93 has to move. On the right, plain numbers are okay. The 155 is okay. So there's only one guy to move here. The plus 93 becomes negative 93. Okay, what do we end up with? Well, 30e on the left equals, let's see, what are we going to have here? I think it's going to be 62. Positive wins by 62. Okay, there we are. Now, we want to find out what e is, so divide both sides by 30. Here we go. Okay, so now let me work over the right a little bit here where I've got some room. We can continue on. Okay, the e on the left, remember 30 divided by 30 gave me the e. Now we can do some reducing here. 2 goes into both of these. 2 goes into 30 15 times. 2 goes into 62 31 times. So I've got e equals 31 15ths. Now, this is a word problem. You can leave improper fractions as answers in regular algebra problems, but word problems are for public consumption, you know, solving real everyday problems. And in general, the public is not too familiar with improper fractions. A little better luck if you convert this back to a mixed number, so that's what you should do. So what's the e going to equal here? Well, remember, 15 goes into 31 twice. 2 times 15 is 30. There's one part left. So 2 and 1/15, that's the extra. And of course it's cups. So don't forget to put down what the units are. So because this is a word problem, you do want to take an improper fraction and convert it back to a mixed number. What were the number of extra cups in this problem? 2 and 1/15 cups, too much. Okay, here's another one to look at. In this word problem, we say find the price of one marker if 10 markers cost $64.70. Well, okay, again, we want to make sure we solve this. So the price of one marker, let's say P equals the price of one marker. Okay, now, here we go. 10 markers cost $64.70. So, if P is the price of 1, to get the price of 10, we've got to go 10 times P. So there's the price of 10, and they told us that equals $64.70. We'll put the dollars back in the as the units when we finish up here. Okay, well, this can be the equation right here. Remember, you do have to give the equation. You might have a different variable, but there it is. Now, simply divide by 10. This is 10 times P, so I got to divide by 10 to get a single P. But that means I've got to divide the right side by 10 as well. Okay, the 10's cancel out here. We get P equals. Now, dividing by 10 moves the decimal point back one place to the left, and so we end up with 6.47. And, of course, this was in dollars, so don't forget to put the units back down. That was the cost of a single pen, $6.47. Okay, here we go. Pazra wants to buy a hat for $27. She gives the cashier $40. What is her change? Let's say C equals the change that she should get. Now, we know that the cost of what she bought plus the change she should get back has to equal the total amount that she was given. So, 27 plus the change has got to equal the total $40. Now, you could have also set this equation up as C equals $40 minus the 27, and guess what? Once we start solving this is exactly what's going to happen when we move this plus 27 over. So those two equations are entirely equivalent, and you could give either one of them as the equation to solve this problem because they're both exactly the same. But whichever one you give, remember, you've got to give an equation example. You could have, of course, a different variable here. Now, if we go to solve this, remember, of course, as always, our goal here is C equals whatever number the final answer is. So, C's are okay on the left, but the 27 has to move. Numbers are okay on the right, so the 40 is okay. So this plus 27 would come over as negative 27, which may have been how you might have written the equation in the first place, but they're entirely equivalent. What do we have left here? Well, the C on the left, 40 minus 27. The positive 40 is going to win by, I believe, 13. And, of course, this is all in dollars, so be sure you put the dollars notation down there. Okay, Shauna won 65 lollipops playing horseshoes at the county fair. At school, she gave one to every student in her math class. She only has 34 remaining. How many did she give away? Let's say G equals the number that she gave away. Okay, well, here's what we know. She originally had 65 of these. Okay, so if we start out with 65, what we do is remove the one she gave away, which is our G, so minus G equals the ones remaining, 34. So originally she had 65. She gave away some here. We're using the letter G to represent that. And of course the one she gives away reduces the amount, so that's how come we have the minus. And of course then what she has left after she does this is 34. So there's our equation. You could have put it in slightly different forms, but that's the idea. Now, what we want to do is solve this. Okay, well, remember, as always, our goal here is G equals whatever number the answer happens to be. So, the negative G is okay. G's are okay on the left, but the 65 has to move. Numbers are okay on the right, so the 34 is okay. So this is the only guy that has to move. He's plus 65, so he comes over as negative 65. So I've got negative G equals, and here we are, 34 minus 65. Well, I think negative's going to win by, what is it, 31? So there we go. Now, there are a number of different ways you can clear this up. You can't leave the answer like this because what you're doing is not telling folks the actual number she gave away, but the minus in front means it's the opposite number of what she gave away. Well, you can see what the answer is here, but let's go through this officially. Now, here's one way to tackle this. You don't see a number in front of this G. Well, if you don't see a number, then you can assume that it's a 1. So if you put that there, then notice what this looks like is negative 1 times G. Well, you've got to do the opposite, which is divide by negative 1. But if you do that to the left side, you've got to do it to the right side. Well, the 1's don't reduce out. You got a 1 there already. The 2 minuses give you a plus. So any way you want to work this up, you're going to end up with a plus 1G. So over here on the right, where I have a little bit of room, let me write that down. G equals, now 31 over 1 is just 31. The 2 minuses give you a plus, so this is positive 31. Okay, well, now don't forget to label this. 31 what? Well, it's 31 lollipops, so make sure you put down lollipops here. That's how many that she gave away. Okay, one last example to take a look at here. Here we go. Carlos and 8 of his friends went out to eat. They decided to split the bill evenly. Each person paid $10.94. What was the total bill? Well, let's say B equals the total bill. Now, notice, how many total people were there that split this? Well, Carlos and 8 of his friends, so that means together here there were a total of 9 people, okay, that were splitting this particular bill. Okay, well, what's it going to equal? Well, if each of the 9 people paid $10.94, then the total bill B has got to equal 9 times. And how much did each person pay? $10.94. So 9 people paying $10.94 each would give us the total. Well, here's a case where you got the B on the left all set to go. What the answer is over on the right. So let's see if we can multiply this out. 9 times 4 is 36. Carry the 3. 9 times 9 is 81, and 3 makes 84. 9 times 0 is 0, but I got that 8 I carried. And then 9 times 1 is 9. There are 2 decimal places. And of course, we better put the units in. This is in dollars. So what was the total bill equal to? $98.46. And each of the people paid $10.94. That's how we figured it out, 9 times $10.94.